Hi there, this is Professor Eckhouse, and I'm going to talk today about proportions and their applications. So recall that a ratio is a comparison of two numbers, A over B, with no units, or the units cancel out. A rate, so we're comparing here a ratio and a rate. A rate is a comparison of two numbers as A over B with units. So it has units on the top, like miles per hour or dollars per box or whatever. All right, so writing proportions. A proportion states two ratios or rates are equal. Looks like this. That is a proportion. So make sure you have this as the definition of a proportion. This is read as A is to B as C is to D. And that's how you really need to think about it in your head. So if you're thinking about it as a proportion, you would say this next one, 1 is to 2 as 4 is to 8. The next one, 20 students is to 1 teacher as 60 students is to 3 teachers. So which one is a rate and which one is a ratio? So this one is a ratio. It has no units. And the next one is a rate. It does have units. Students to teachers. All right. So we're going to write each sentence here as a proportion. I'll show you what that means. Now, the first one I want you to think about, is this one a rate or a ratio? There are no units, so this is a ratio. The next one, 20 miles in 1 hour, well, this is going to be a rate because it has units. The next one is dollars for every ounce, and that one is also a rate. So let's look at how to write these as proportions. So 5 is to 8 as 15 is to 24. All right, 20 miles in 1 hour or per 1 hour, or 20 miles is to 1 hour as 60 miles is to 3 hours. Now, I prefer to do the is to with things that don't have units. Okay, so if this has units, it's easier to think about it as what it really is. 20 miles per 1 hour is to 60 miles per 3 hours. All right, the next one, $3 is to 6 ounces or per 6 ounces as $4 is to 8 ounces. Or $3 per 6 ounces is the same as $4 per 8 ounces. All right. So there's 2 ways to test a proportion, and that is the main thing you're going to be asked to do, that and solve for an unknown in a proportion. So one is to divide. All right, so we're going to divide 1/2 on the left in your calculator. So 1 divided by 2 is 0.5. Divide 4 over 8 and you get 0.5. Those are equal, so this proportion is considered true. It is true. 1/2 really, 1 is to 2 as 4 is to 8. That is true. All right. Another one is not really my favorite because people misuse it, but we'll use the word cross multiply because that's what people know. But really what we're doing is we're multiplying both sides times 2 and both sides times 8. That's what we're doing. But we're going to do this is the shortcut, and we get 8 times 1x equals 2 times 4x. Right, so we get 8x equals 8x. All right, another way to test is to see if they are equivalent fractions. This does not always work, so it's not one of the 2 main methods, but sometimes it gives you a fast way to check if the 2 numbers are obviously equivalent fractions. And so what you want to think about is, if I multiplied 1 times 4, then would I multiply 2 times 4 to get 8? Yes, so they are true. So they're true here, they're true. This is true by cross multiplying, so these are all true. Okay, so let's practice determining whether proportions are true or not. All right, so we're going to do both ways. So the first way I'm going to use is I'm going to divide. Okay, so I'm going to divide and trying to figure out where to write this. So 3 divided by 7 is 0.4286. So I'm going to divide first. 0.4286. All right, does that equal 12 divided by 21? Well, when I do that in my calculator, I get 0.57. Ooh, no, not true. Not true. All right, the other way is to cross multiply. And I get 21 times 3 equals 12 times 7, not 17, 12 times 7. And that becomes 63 equals 84. And, you know, that is not true. None of them are true. So not a proportion, no. All right, so I'm going to write, just I have more room over here on the right, so I'm going to write on the right. So 15 over 23.5 is 0.6596. I'm going to do this by dividing first. And the right side, 62 divided by 96, is 0.6458. Those are not equal. So I'm going to say no. You could test it with cross multiplication. So I would say cross multiply. And I'm going to get 96 times 15.5. Does it equal 62 times 23.5? And when I do that on my calculator, I get 1488 equals 1457. And those are not true, so no. Either way you do it, and you do not have to do it both ways. I'm just showing you both ways, and you can pick your favorite. I personally like dividing. It's just, I don't know, it's just faster, I guess. But you can do whatever you want. Cross multiplying works when you have an unknown quantity. All right, so why don't you try the next couple, 3 actually. You should try the next 3. Pause the video and give it a try. All right, so I'm going to do divide, and I'm going to do cross multiply for each one. And this is just going to be my header for all 3 problems here. All right, so dividing, I get 10 divided by 12 is 0.83 repeating. And does that equal the right side, 90 divided by 108? And I get 0.83 repeating. It does. So I think the answer is going to be yes. Okay, so let's write yes. This is a true proportion. And I'm going to come back up here and I'm going to write, just to make sure it's really clear, not equal to. These are not proportions. They're not equal to each other. All right, so I'll show you with cross multiplication. This one would be 10 times 108 equals 12 times 90, and I get 1080 equals 1080. Okay, so those, either way you try it, they are true. Let's do the next one with division. So 7.25 divided by 12.8, and I get 0.5664. Does that equal 58 divided by 102.4? Well, that side is 0.5664. Look at that. So the answer here is yes, these are a true proportion. Let's try it with cross multiplication. And I get 7.25 times 102.4 equals 58 times 12.8. So I did a cross multiplication here like this. All right, I get 742.4 equals 742.4. So if you did it by cross multiplication, that's what you would find, and you would again say, yes, these are true. All right, there's one more I'm going to show 2 ways. And this one is 0. If I divide 4.7 divided by 11.1, I get 0.4234. And if I divide 23.5 by 54.2, I get 0.4336. They are not equal to each other. So no, this is not a true proportion. Not true. All right, so let's try multiplying this one out. I'm going to do cross multiplication, and I get 54.2 times 4.7 equals 23.5 times 11.1. Doesn't matter what order you multiply those in. And you get 254.74 equals 260.85. So again, obviously not equal to each other. So it's not a true proportion. All right, so we're going to do a few solving proportion equations. The goal is to isolate the variable on either side on top because we're solving an equation. So solving an equation means we find what the variable equals. Okay, so there's a difference between solving and evaluating. Solving, we're finding the variable. Evaluating, we're just plugging in a number for x and finding what it would be. That's not what we're doing here. Okay, so we're going to use cross multiplication here, and I'm going to rewrite this problem just so it's a little bit bigger. X over 54 equals 5 over 6. And we're trying to find what x would be so that whatever it is over 54 is the same as 5 over 6. So they're equivalent fractions. Some of these you could do with equivalent fractions, but I'm going to show you with cross multiplication. So like I said at the top, cross multiplication is not always the easiest choice. Only use it when the variable is in the denominator. So this one is going to be called half cross multiplication. So if x is in the top, there is no reason to bring 6 over to the left side, right? If I multiplied that over there, now I've got more work to do. So I'm trying to keep this to be less work. So this just uses algebra. We're just going to multiply both sides times 54. Or do half cross multiplication if that's what you want to think about it as. I prefer thinking about it as algebra because then it applies to all sorts of different things. Now we've got x equals 5 times 54 divided by 6. If you put that in your calculator, you're going to get 45. So now let's double check. We just found that 45 over 54 equals 5 over 6. Now, a few different ways to think about this. If I took 45 times 9, I would get 5. If I took 54 times 9, I would get, divided by, I'm doing this too early in the morning, divided by 9. So I've got divided by 9 to get 5, and 54 divided by 9 to get 6. All right, another way to do it is to test in your calculator or cross multiplication, whatever you want to use. So all the ways to test a proportion, those all three ways work here. All right, let's try the next one. So you give this one a shot. All right, I've got x over 10 equals 14 over 8. Now there's no reason to do cross multiplication here because it would bring 18 over here, which would give us more work to do. We want x by itself. X by itself. So it is being divided by 10 right now. The inverse operation of dividing is multiplying. So I'm going to multiply both sides by 10. The 10s are going to cancel out here. And I get x equals 14 times 10 divided by 18. You can just put that in your calculator all in one big long step. And you get that x equals 7.7 repeating. Okay, 7.7 repeating. Now you could take that and put it in your calculator over 10 and see that you got the same thing when you divide 14 by 18. Test the proportion. Make sure you got it right. All right. There's a couple more here. Why don't you give these a try? All right, so hopefully you see that the last problem, again, had the x in the top, and this one too has the x in the top. So we're going to just do the same thing as before. X over 19 equals 13 over 15. We're going to multiply both sides by 19. And we get that x equals 13 times 9 divided by 15, and that gives us 16.46, and the 6 is repeating. So it's 16.466666. All right, I'm going to erase that 6 because that's a mess. Okay, let's go on to the next one. X over 12 equals 8 over 15. So x over 12 equals 8 over 15. I'm going to multiply both sides by 12. The 12s are going to cancel out, and I get 8 times 12 divided by 15, all in your calculator, all in one step. 8 times 12 divided by 15, and you should get 6.4. So again, that means 6.4 over 12 equals 8 over 15. And you can check your work by just putting those in your calculator. Make sure that two sides are equal. In whatever your preferred way of checking proportions is works. Any of them work. Okay, let's move on. Now x is in the bottom. What are we going to do about that? So the best thing to do with these is to do cross multiplication. So x in the bottom, in the denominator, right, do cross multiplication. And it's going to require one more step. Cross multiply plus one more step. Okay, when it's in the bottom. All right, so I'm going to rewrite this. 90 over x equals 8 over 3. I am going to cross multiply. In other words, I'm going to multiply both sides by 3 and x. All right, so then I get 90 times 3 equals 8 times x. All right, now I'm going to have to divide both sides by 8, and that's the second step, right? That's the one more step. The 8's cancel out, and I get 90 times 3, which you may have already done ahead of time, and then divide it by 8. So you get that x equals, x is on the right, but it still equals, right? So I can write it first if I want to. X equals 33.75. So now you can test it. 90 over 33.75 equals 8 over 3. Does it really? Test it and see. Just divide both sides and see if you get the same decimal. All right, try this one. So that one's just for you. All right, so we got 52 divided by 91, or 52 is to 91, as -4 is to x. All right, so I'm going to cross multiply, or multiply both sides by 91x is basically what we're doing. Just a little reminder. We get 52x equals -4 times 91. All right, so if you want to work out the -4 times 91 ahead of time, you can. I did not. I just like keeping my steps brief. So I can do everything in my calculator all at once. The 52 divided by 52 gives me x equals -4 times 91 divided by 52. Put that all in your calculator, all in one step, and I get -7. So now you can check. 52 divided by 91 in your calculator, is that equal to -4 divided by -7 in your calculator? And it should be. All right, so now we're going to look at some application problems. So the key to success on these is to watch the units. The units in the denominator must match, and the units in the numerator must match. So what's on top must be the same unit. All right, so when pediatricians prescribe acetaminophen to children, they prescribe 5 milliliters of acetaminophen for every 25 pounds. Okay, so that is 5 milliliters for every 25 pounds. I'm going to abbreviate pounds. If Zoe weighs 80 pounds, how many milliliters? All right, so how many milliliters? That means that the question is question mark milliliters, or X milliliters, right? So that's what we're going to put. Now, where does it go? Milliliters was on top, so we're going to keep it on top. X milliliters for every. Now, Zoe weighs 80 pounds. Okay, so this is how you solve problems with proportions. All right, now we can do the problem without the milliliters and pounds if we want to. As long as we have it started here, we can now do it without. So I'm going to use cross multiplication, and I get 80 times 5 equals 25 times our x. Notice I dropped the units, just it's less to look at. Now I'm going to divide both sides by 25. And I get that x equals 16 milliliters. Now make sure it makes sense. Don't kill the child, right? We've got 5 milliliters. We don't want to give them 2,000 or 160. So, make sure it makes sense. If they prescribe 5 milliliters for 25 pounds, 80 pounds is like a little more than 3 times that. A little more than 3 times 5 is 15. So 16 makes sense. So you need to listen to that again too, because that is proportional reasoning. That's just thinking about it proportionally. All right. One brand of microwave popcorn has 120 calories per serving. A whole bag of popcorn has 3.5 servings. How many calories are in the whole bag? So 100 calories per one serving. So there's no number there, so a lot of people lose that per one serving. A whole bag of this popcorn has 3.5 servings. How many calories are in a whole bag? So this is going to be question mark calories or X calories. So we need to decide what's going to go on top and what's going to go on the bottom. Well, I like to solve for things that are on top. It is so much easier. So how many calories? I'm going to put calories on top so that X is on top. Okay, it won't hurt anything if it's not. It just makes it easier. 120 calories per one serving equals. Now we've got to take the green one. So that's the yellow, right? I just did that, the yellow side. Now the right side is going to be green. So 3.5 servings. Where should that go? Top or bottom? Hopefully you see servings is on the bottom, so we need to stay consistent. Right? And then X calories goes on top. All right, so we've got X calories per 3.5 servings. So let's say this to ourselves. 120 calories is to one serving as X calories is to 3.5 servings. Okay, that looks good. So now I'm going to multiply both sides by 3.5, or I'm going to do single cross multiplication, however you want to think about that, but I like the times 3.5 on both sides, and the 3.5 is going to cancel out. And I get 3.5 times 120 over 1, that's so nice, over 1, so equals X. So just 3.5 times 120, and I get 420 calories. So make sure you watch your units. So X was calories, so you need to put calories on there. Okay, a couple more. Josiah went to Mexico for spring break and changed $325 into Mexican pesos. At that time, the exchange rate had $1 US equal to 12.54. So there's our exchange rate right there. $1 US equal to 12.54 Mexican pesos. How many Mexican pesos did he get for his trip? Okay, so this is our $325. And how many Mexican pesos did he get? So there's not side by side in the question, so you really have to be careful. So the question is going to be question mark pesos or X pesos. Now, I would like that to be on the top, personally. So I'm going to put pesos on top when I start. So here's my starting point, 12.54 pesos per $1 US equals, now we're going to have pesos and dollars over here on the right. So X pesos is my unknown. Okay, so we've got our kind of given ratio on the left. So 12.54 pesos is to $1. As how many pesos? X pesos is to $325, which is how much he's exchanging, or she is exchanging. All right, so we've got 12.54 times 325 over 1. So it's nice that it's 1, and that gives us X. So since I'll give myself a little more room, so we've got 325 times 12.54 is 4,075 pesos. That equals X. That's what we just found. So be careful with your unit. Keep track of what it is that you're looking for. That's why it's helpful to write this right up here. All right. One last thing that we're going to talk about here, and that is finding percents using proportional reasoning. So you will see a problem like this in various places on the homework and maybe in the knowledge check. So find the following percents of 300. So 1% of 300. So 1%, what is 1% of 300? Well, that's going to be X. So how we do that is X is 0.01 times 300. and that's going to give us 6. Another 6? Goodness. 3. I was looking at a different answer. 3. All right, so same thing. What is 10% of 300? So x is 0.1 times 300, and that is 30. What do you think we did with 300? With 300 to get to 3 and to get to 30? So 1%, you just move the decimal point back 2 places to get to 3, right? So you go 1, 2, 3%. 1% of 300 is 3. I'm getting tongue-tied, sorry. Then, if you want 10%, you just move back 1 place. So finding 10%, you only move back 1 place. So you move back 1 place to get 10%. 1 decimal place. And for 1%, you're going to move back 2 decimal places. Right, I'm going to rewrite this because it's a mess. I want to make sure you can see it. So move back 1 decimal place for 10%. Okay, well that makes it easy. So keep that in mind when you're doing tip, right? So how would you do tip? Let's think about that in just a moment. All right, so now use proportional reasoning, no calculator, to find 2%. Well, if 1% is 3, then 2% would be double that, right? So 2 times 1%, right? That's 2%. So if 1% is 3, we're going to say 2 times 3 is 6. So 40%, how could you quickly find 40%? Well, move the decimal place back 1 to get 30, right? So 40% is 4 times 10%. Well, what is 10%? That's 40%, right? What is 10%? So 4 times 10% we just found right up here is 30. So 120. So 40% of 300 is 120. Hardly any math required for these. Well, let's do a harder one. Try see if you can figure out from what we just did above, without using your calculator, what 32% is. All right, so I would say, well, I know what 2% is. 32% is going to be 30 plus whatever 2% is. So 3 times 10% is going to give us 30%, right? And then 2 times 1% is going to give us 2%. When we add those up, we get 32%. Okay, so what is 10%? 10% was 30. So 3 times 30 is 90. 2 times the 1%, right, is 2 times the 1% was 6. So we get 96. So 32% of 300 is 96. No calculator. So how could you do this with a tip? Right? So say your bill was $300 and you're trying to pay 20% tip. Well, 10% of 300, we just found out all we have to do is move the decimal point back 1. So 10% is 30. So 20% is going to just be double that. So that would be $60. So a 20% tip would be $60. No calculator required. So find 10% by moving the decimal point back and then double it to find 20%. That's why I always just leave a 20% tip. So much easier. All right, that's all I have to say. Thanks for watching.